What's up, everybody? I am not a software engineer, but today I'm going to walk you through how you can create your own clone of the popular casino game Plinko. Now, this game is typically found on sites that happen to be banned in the part of the world that I live in, and I also don't like spending a ton of money in a losing fashion, but I do find these games pretty fun. So I'm going to have a slight disclaimer here in that this is for educational purposes only. And I do think that this game does have quite a few computer science problems that are pretty challenging for the novice, such as myself. And yeah, we're going to go ahead and work through those. So, this is what the game actually looks like. And basically, the premise of the game is that you click. And that actually drops one of these red bouncing balls, and they basically bounce off the obstacles that you see here. And so in this screenshot, you can kind of tell that there is a slight animation that occurs each time a ball hits an obstacle, and eventually they will hit one of these multipliers down below. And to give you an idea, most of the occurrences are going to be 0.2 times your initial bet. So if you bet $1, the odds are you're going to get 20 cents back, which obviously is a losing game, and thus how the casino makes profit. Now, in the version that I'm going to make, we're going to see that controlling the probability is actually a little bit more difficult. So if you wanted to create one of these and put it in your own casino, you would have to have much more strict probabilities. Otherwise, you would end up paying your players too much money and inevitably go broke. But since this is just for fun and for educational purposes, we're not going to care so much. And we're basically just going to clone the visual aspect of the Plinko game that, again, you might find on popular casino websites. So, I have decided to basically create a new repo that is based on my Pygame project template. And so this is what our start looks like here. Now I can open that in VS Code. And I have made a few modifications so we can go ahead and get started. So we're going to go ahead and walk through this. I did not want to code this entire settings file, but if you wanted to do this manually, I totally understand, and I do that quite frequently when I do tutorials myself. But I did make some changes to this template that, again, is in my Plinko repo because I am not creative at all. And I wanted to kind of walk through what I've done that is different from what you would see if you just created a new repo based on that template. So I have added a few different audio samples, and they're all numerically named MP3 files, but basically they are going to be played when a certain multiplier is hit. The higher the multiplier, the higher the frequency of the actual note, and we're going to adjust the volume as well. So beyond that, I have taken to the ChatGPT image creation tool to create an AI-based or AI-generated play button that we're going to actually press. And when we press that button, it's going to kind of look like it is actually being pressed in. And by that, I mean I've just kind of created like an inner shadow or something like that using Photoshop. I didn't want to go through the actual image generation, but I did use OpenAI tools, which are pretty handy for this kind of thing. So beyond that, we pretty much have a very basic Pygame setup. And I wanted to go ahead and create a couple new files here, because when we go back and we actually look, we're going to have a class for our ball. We're going to have a class for our obstacles. We need a class for when the obstacles are animating. We need a class for our multipliers here. And then I think we need a class for our previous multipliers as well. So this little display on the right side basically is going to take, like this one right here looks like it's about to hit a 2x. So as soon as this ball collides, and you'll see why I'm using the word collides shortly, but as soon as this ball collides with our multiplier, then this 2x is going to drop in as well. And that just kind of gives you like a visual cue of the previous multiplier that was hit. So we do have quite a few classes to create, and we're going to have an overall encompassing class as well that we're going to call board. So I'm going to go ahead and go back over to our VS Code window and create a couple new files. So one is going to be ball.py, and as you can imagine, that is going to contain the ball class. We're also going to create board.py, which is going to create our board. And then we're going to have multis, which, surprise, contain multis. And then obstacles for obstacles. And that should do it. So we need to start filling these out, and I want to do it in an order that kind of makes sense. So for me, the first thing that really kind of makes sense is we need to take a look at main and see what we need to actually create. And actually, I'm going to go ahead and launch this just so we can see what it looks like. So this just brings up a blank screen. Now we do have our Plinko ripoff in the top left, which is doing what we want it to do. But I am actually going to go so far as to take the same color, and we're going to go ahead and make our first change, which is just going to be changing that to the color of the Plinko board that you see here. So I have done a bit of research, and by research I mean opening this in Photoshop and then grabbing the RGB value, which I believe is in settings. So yeah, let's go ahead and go back to settings and walk through it a little bit, because there is a bunch of stuff going on, and I will be referencing this constantly. But one of the things that I'm going to reference is the BG color, right? So BG color is an RGB tuple that is set to the color that we saw in that screenshot that, again, I will be referencing as well. So we can go back over to main, and we can see that I have a self.screen that is being declared, and that is set to our width and height, which is just going to be the 1080p, or rather 1920 by 1080 resolution. And so one thing that I'm not actually doing yet is filling the screen with the BG color. So I need to go ahead and do that, and I can do that by creating a new little line in our while loop here, and that will just be self.screen.fill BG color. So right now I should be able to get the result of that quite easily, and I do. I'm going to make some slight modifications to the time variables. And so delta time is actually just going to be self.clock.tick FPS divided by 1000. And then I don't actually need start time. And you'll see why I'm doing this, but I'm actually going to set the frames per second in this project to 60. And we're going to start using a library called PyMonk. So I'm going to go ahead and have an import here for PyMonk, but basically that is going to take care of our physics, gravity, and the bouncing that the actual balls do off of the obstacles. And so I need to add an import here, and that is just going to be PyMonk. And so I basically need to create space using PyMonk, and I did a few tutorials that I am going to link in the description of this video that were very helpful in understanding how to leverage PyMonk. But for now, we will just add a PyMonk section here, and I'll have self.space set to PyMonk.space, and then I'm going to set the gravity, self.space.gravity equal to 0, 1800. So in some tutorials you will see a negative value here, but due to the way that resolution works in Pygame, we actually need to have this be a positive value. So in lots of tutorials you'd probably see negative 1800 here, but since I'm using Pygame, we're going to use 1800. And so I also wanted to create a group here, because every time we spawn a ball, it actually needs to be in a group so we can do certain things like animation and things of that nature in the group. And so I'm going to have a separate section here called Plinko setup, and that will contain self.ball group set to pygame.sprite.group, and we'll also have our board object, which we have not actually created any logic for the board class, but that will just be self.board equals board. And in that, we need to actually pass our space, our PyMonk space, so self.space will go here as well. And so I would like to have basically a debug as well, debugging. And this actually came up a few times in testing. So self.ballsPlayed equals 0. We may reference this if we need to debug. If not, this will just probably just sit here and do nothing, which is fine. So a couple other things. We also need to have, and basically this occurs right here, whatever is in this statement happens every single tick or frame, right? So we need to do some things with PyMonk as well. And I will just create another section here, pymonk self.space.step. It basically tells pymonk the frequency that it should update its gravity, right? So we're going to do that with self.delta time. And then we're also going to call the update function and our board class, which does not exist yet. So self.board.update. And then we also need to do the same for our ball group, self.ballgroup.update. And I don't actually think that we need this. All right, I like that order. Let's see if that works. And of course, we don't actually have anything in board. So I do need to do a series of imports here. So I'm going to start with ball. From ball, import ball. From board, import star. And I'm just going to do all the imports that I know that I will need. From multis, import star. And we already have settings. So this should be good, actually. So what we need to start doing is filling out our board class. Since that is the error that we got, board is not defined. So we'll go ahead and begin doing that. And in the board.py file, we need to do a series of imports as well. And I'm just going to copy and paste it in. But then we're going to create our class board. And basically, there's only going to be one object of the board class. And that is going to be responsible for quite a bit. That's going to spawn obstacles. That is going to spawn our multipliers at the bottom of the obstacles. And that's going to be responsible for updating. Or there's going to be an update function that does quite a bit with those things as well. So this will be somewhat lengthy, and we're just going to walk through it. So def, our init function, is going to take in self and space. And then we're basically just going to have our space equal to space. So self.space equals space. And then we also need an object of the Pygame.display get surface, right? So self.display surface equals Pygame.display.get surface. So we're going to start with our obstacles here. Obstacles. And when we go back over to the screenshot, we see that the initial row has 3, right? And then the final row has 18. And again, these are obstacle counts. But that is going to give us the ability to kind of have a loop, right? That basically creates 3, then 4, then 5, then 6, so on and so forth, all the way until we hit 18. And we're going to actually need to do something with the spacing between these. But if we go back to our settings.py, there actually is a variable that determines the spacing between obstacles. And then if you notice here, the space between this and this on the x-axis is half of what it is here. So there is a bit of logic in settings.py that helps us do all of that. But when we go back over to our board class, we can go ahead and have our current row count set to 3. And then we'll have our final row count set to 18. And we also need to create a list. So our self.obstacles list will be blank at first. And then I'm also going to have a sprite group version of that, which is going to be self.obstacle list. That is somewhat confusing, but it is what it is. Pygame.sprite.group. And then finally, we're going to have something called updated coordinates, which is just going to be self.updated coords. And that's going to be equal to obstacle start. So I've referenced settings quite a bit. Let's go ahead and go back and talk about what's going on here. So our obstacle color is going to be white. The radius of our obstacle is going to be the width, which is 1920, as you see here. But in case we need to change the resolution, this will just update without me having to change this as well. So it's just going to be 1920 divided by 240. So the radius of our obstacles is going to be 8. And then the pad, which is the distance between obstacles, is going to be our height value divided by 19, which happens to be 56. And so our obstacle start is going to be the location at which we actually start to draw obstacles. So we go back here, and that is going to be in this general area. So this is not a 16 by 9 aspect ratio, but basically I guess the initial middle of the first row is actually like smack dab in the middle of the screen in terms of the x-axis, right? So that is basically what I aim to do with this coordinate value. And so, yeah. We have a segment that we need to create. We're not going to talk about that yet. Our ball radius is going to be 16. Multipliers, this is just a dictionary that will keep track of how many of each multiplier that we hit, and we'll actually print that out to the console. And here are RGB values. So we'll keep referencing this quite a bit. So now we're going to go ahead and start spawning our obstacles, and we're going to do this in the init function. I could put this in a separate function and then just call that once, which might be a better design. But in any case, this is how I ended up doing it. So we need to create basically a while loop. While self.cur row count is less than or equal to self.final row count. And again, this is just drawing row by row and accounting for the space changes each time we move to a different row. So we're going to have a for I in range self.cur row count. And so what we're going to do is actually add a new obstacle to our obstacles list. So remember, our obstacles list is actually just a Python list, right? And maybe I should actually call this obstacle sprites. That'll be a little bit less confusing. So our obstacles list is going to actually be appended to by calling the spawn obstacle function, which we have yet to create. But what I'm going to do is just have a self.spawn obstacle, and we need to pass in our updated coords. So that's just going to be self.updated coords, and then we also need to pass in the location that this should go, and that is going to be in self.space. So what we're going to do is we'll just walk through the first iteration of this, right? So while 3 is less than 18, for I in range 3, so this will happen 3 times, we are going to take in updated coords and the space, and we're going to pass that to self.spawn obstacle, or rather just spawn obstacle, which has yet to be created. But that function is then going to return or give us rather an obstacle that will be kept in the obstacles list. So before I go too crazy with this, I'm just going to create this new function here called spawn obstacle. And of course that's going to take in self, and then what did I call coords? Position and space. And for now we'll just have this pass. But then we need to update our coords, right? So each time this loop runs, we need to update the coords. So I will do self.updated coords, and I'll set that to int self.updated coords. And I'm going to get the x value here, which is just going to be the 0 index, right? Because this is a tuple that has an x and a y value. So I will take the x value and I will append our obstacle pad, which again is set to 56, right? So this is just going to change the x value by 56. And then our y value can stay the same for now. So that will just be self.updated coords. And then the 1 index is just the y value. And there are no changes yet on the y value. Okay, so this will basically make, and again, this is when current row count is set to 3. This will create 3 obstacles. And it will basically add that obstacle pad. The y value will stay the same. Now, once we get out of this occurrence, so the first time, once this happens 3 times, then what do we do? Well, we basically do need to change the y value now, because we're going to jump to a new row. So we're going to do something with self.updated coords. And we're basically going to set that to the int value of width minus self.updated coords, and this is just the x value. Then I'll have and when we talked about this, I mentioned that it's half of the value of the pad, right? So we can just do a 0.5 times obstacle pad, and then we also need to update the y value. which will be the int value of updated chords y plus obstacle pad. So that 56 also works for the y value. And that should update the coordinates the way that we need them to go to the next row. But we do need to append, or rather increment, our current row count. So self.cur plus equals 1. Now that should work for all 18 rows. And we could actually just print out the result of that, right? So print self.obstacle list. And I think that will work. Oh, we still don't have a ball class though. So let's go ahead and create one class ball. And we will just have this do nothing for now. And I believe I'm missing a parentheses here. And I have one extra here. So let's try that again. And so it's actually good that I did change the name of this, because it would have thrown me off. But yeah. Okay. So since we're calling update, we need an update function. Def update. This should be good at this point, so I think we can run this. All right. So we actually do get some detail. It's basically just a list of none. But in theory, we do actually see that we are adding stuff to our obstacle. Now we don't want the value to be none, right? So we need to actually fill out on obstacle, because right now it's doing nothing. So let's move on to filling out the spawn obstacle function. And basically what we're going to do here is create a new PyMonk body. And so there are 3 different types of bodies in PyMonk, and the one that we're going to use is actually static, which means that this is not going to move at all. It can interact with other objects, but it's not really affected by gravity, so it's just going to be stationary. So our body is going to be set to pymonk.body, and the body type will be set to pymonk.body.static. And then we'll also have a body.position, and that will be set to the position that we take as a parameter here. Finally, we will add a bit of friction here, which means that it will slow down objects that collide with it a certain amount. And there's actually a guide on the PyMonk documentation that explains different materials that you can kind of achieve a certain simulated friction of, right? I can't remember which one I chose, but I did go with 0.6. Then I will have a shape set to pymonk.circle, and that will just take in body and the obstacle radius. So that's basically just creating a circle with a radius of 8, and that is going to be based on the body here. And I'm going to add some elasticity, because we do actually want this to bounce objects that collide with it. Shape.elasticity. It's going to be set to 0.4. And so what I would like to do, and this gets a little crazy here, but I do want this to have a specific filter, meaning I want it to be a certain type of shape in PyMonk. Now the reason is, I'm going to go back to the screenshot, but you can see here 2 of the balls are colliding right here. I don't want the balls to bounce off of themselves, but I do want them to bounce off of the obstacles. And in order to do that in PyMonk, we basically need to have the obstacles basically need to have a certain filter instead of the balls, right? And so I will go back over here, and we're going to create a shape.filter, and that is just going to be pymonk.shapeFilter. Categories are going to be obstacle category, and the mask is going to be obstacle mask. And those are both in our settings, right? So we go back to settings. We'll see that the obstacle category is actually down here a bit, and we have 2, right? And the ball category will be 1. And our mask is set up so that the balls will actually collide with all masks except for those that are in the ball category. So that basically just means everything but itself, right? The obstacle mask will collide with everything. It will never collide with obstacles, though, because they don't move. But the all masks does apply to the ball category, so they will collide with balls. So we'll go ahead and go back over to board.py. Now that we have created the filter, we can self.space.add the body and the shape. So we do need a bit more information here. We do want to create an actual obstacle object, which if we look at obstacles.py, we have nothing here yet. But for right now, I do want an obstacle equals obstacle body.position.x and body.position.y. And there's reasons why I'm also creating a sprite out of this, I believe. And that is because I do want to check collisions for my animation. So we'll get to that a bit later. And now I can just self.obstacle sprites our obstacle. And finally, we'll return the shape. So since I'm not actually doing anything here just yet, let's go ahead and comment that out. So in our update function, we will call our draw obstacles function, and that will just take our obstacles list as an input parameter. And so we do need to create that function, and that will just be def draw obstacles. That will take in self and obstacles. And we will have a for loop here for obstacle and obstacles. And then we'll get the position X and position Y, so pos X and pos Y equal int obstacle.body.position.x, and the same for the Y, so int obstacle.body.position.y. And then finally, we can just use Pygame to draw a circle. So the way that we do that is call pygame.draw.circle self.display surface, right? Because we're going to draw it on the display surface. The color of our obstacles is going to be 255, 255, 255. And then we need the position, which will just be pos X and pos Y. And finally, the radius is just going to be obstacle rad. Now, with any luck, we should actually get our board drawn fully when we run this. We have a couple things wrong here. One is that we're still printing that, which we no longer need to do. So this is actually an interesting bug. We need to have our general setup be above these here. So I just move this stuff around, and now we should be able to run it. Nice. So as you can see, our while loop actually worked. We did increment the rows, and then we basically created our obstacles, and that looks really nice as compared to the actual Plinko screenshot. So I don't know about you, but I do think that our game is a bit boring thus far. So I think that we need to have some logic in main.py to actually spawn a ball that will then fall into the board and give us an idea on how we can start actually adding a score, or rather a multiplier component to the game, because that really is the entire point after all. So I basically need to add something that occurs in our event handler here, right? So basically we're looking for events that occur and are stored in our pygame.event.get. And I want to have something occur basically when a mouse click happens, right? We're going to spawn a new ball when a mouse click happens. So really, we want that to happen on the mouse button up. Now you could do this either way, but I just think gameplay-wise, I'm like half committing when I click, right? But when you lift the mouse back up, that's really when you're like, okay, it's time to spawn a ball. So what we're going to go ahead and do is add an elif statement here. And that's just going to be elif event.type equals pygame.mousebutton_up. And then we're also going to make sure it's the left button, right? So that's going to be and event.button equals 1. Then what we will do is actually create a random x value. And that's because we don't want the ball to spawn in the same spot every single time, right? It's a little boring. So we're going to have a random x set to our width with a floor divisor 2. That means if there's any remainder, it will just get rid of it. Plus random.choice. And so we do have a random import necessity here. I'll add that and go back down to random.choice. And after some testing, I noticed that sometimes the ball would actually land on the middle obstacle and just sit there. So if it drops completely in the center of the screen, it would just sit on top of this, which we do not want. So you're going to see that reflected in my random choice options, right? And that's just going to be random.randint. And we're going to have 2 values here. They're both going to be negative, and that's going to be negative 20 is the lowest value, and negative 1 is the highest value. And then our other choice is going to be random.randint, and you might see where I'm going with this, but we're going to have 1 and 20. So basically, we're just never going to have the possibility of a 0 x value. And that is how I got around the issue where the ball would just sit on the obstacle. So I will then spawn a ball, and that is just going to be self.ball equals ball, and then we're going to have that at the random x value, and 20 is going to be our y value. So we also are going to need a few parameters that we're going to pass to the init function in the ball class, and that's just going to be self.space, self.board, and self.delta time. So delta time is going to help us get closer to a frame rate agnostic game, which unfortunately I did not achieve with this, but I did get pretty close, and I think the differences between 60 and 120 FPS aren't that crazy. And that's kind of why I did my testing in 60 FPS, just to work on a variety of different hardware. But in any case, it does help us get closer to frame rate independence. So I'm also going to add this to our ball group, which is just going to be self.ball group.add self.ball. And that should do it. I just have to make sure that I actually create a ball group just yet. We did. Okay, good. So now it is time to go over to the ball class, which as right now basically just does nothing, right? So we do have a few imports here, and they are similar to the other files as well. So I'm just going to copy and paste them in. And this is actually going to inherit from our Pygame.sprite.sprite class. And we're also going to have quite a few more parameters, as you saw when I created the ball object on the mouse click, or mouse button up rather. So that's going to be position, space, board, and delta time. And obviously we will have to set our values accordingly, but before we do that, we need a super init, since we're inheriting from this class. So yeah, we'll just do that here. And we do need display surface as well. So self.display surface is pygame.display.get surface. And so now we'll just kind of grab these parameters and store them. So self.space is space, self.board is board, self.delta time. So we are going to create a PyMonk body in the init function here. So self.body equals PyMonk.body, and the body type this time is going to be dynamic because the ball will collide with static objects, and it also will move, right? So that's just going to be a body type PyMonk.body.dynamic. And we also need to store our position, which is going to be self.body.position, and that's going to be set to pos. Self.shape will be PyMonk.circle, and that's going to take in self.body and ball radius, which I believe is 16. And we're going to have some elasticity here because we want the ball to actually bounce when it collides with the obstacles. So self.shape.elasticity, and this is a PyMonk parameter. or setting rather, and then we'll have a density. And these numbers, density and mass, I played around with a little bit. I am not convinced that the changes that I made in testing made a significant difference. So I could be using them incorrectly, but in any case, I did set them to self.shape.density, and this was 10,000, and then self.shape.mass was set to 1,000. So I do have a filter here. As we discussed earlier, I do not want the balls to collide with themselves in the case that multiple of them are on the same screen. And so I do need to add that filter self shape filter equals pymonk.shapeFilter. Categories will be ball category, and the mask will be the ball mask. So we're going to add this to our space. Now that the filter is set, self.space.add, self.body, and self.shape. So finally, we're going to create a surface out of our ball and then a rectangle as well, because we need to check for collisions when the ball actually collides with an obstacle. We want an animation to occur, and when it collides with our multis, we want a multiplier score, right? So in order to do that, we do need a rectangle, which does require a surface. So I will create that with self.image equals pygame.surface. And that will be the size of our ball radius times 2. And then ball radius times 2 again. So this needs to be here. Ball rad times 2, ball rad times 2. And then here we'll have the pygame dot, and I believe this is just colors. SRC alpha. And then we'll create our rectangle based on that image above. Self.rect is going to be self.image.getRect. And the location of that will be top left, set to self.body.position.x and self.body.position.y. And that does it for the lengthy init function here. And we'll go ahead and move on to our update function. And that's just going to take in self. So really all we need to do here for now is just draw the red ball. And I'll do that with pygame.draw.circle self.displaySurface, because that's where we're going to draw the ball. And the color of that, you could actually change this to whatever you want. I just made it as red, right? There actually, if we wanted to make this game even cooler, you could select the color that you wanted at the start of the game. But in my case, I just set it to red, which of course is 25500. And the location of that will just be our pause X and pause Y, which have yet to be captured. So we'll do that in a second. And then the ball radius. So I actually skipped a little bit ahead and forgot to do couple things up here, and that's just going to be to capture that pause X and pause Y. Pause X, pause Y are going to be equal to, and this is similar to, I think it was board, but yeah, self.body.position.x and int self.body.position.y. And then we also want to have a rectangle update to that new location as well, right? So this is going to be controlled by the gravity that we have in PyMonk. And so if we don't change our rectangle to basically move with the ball, they will end up in different places. And I did have to debug this at some point. In any case, the way that we can update that rectangle is just self.rect.centerx equals pause X. And self.rect.centerY is equal to pause Y. So now we can just draw the red ball. So let's go ahead and run that and see if it works. Okay, so nothing happens. Then I click. And there you have it. That is pretty much the functionality of Plinko. And really, you could call this tutorial done if you wanted. If you really just wanted that, you know, you're pretty much done. Now, what you'll notice is that there's still no multis. There's no previous multi. There's no play button on the left. And if you watch this, you'll notice that we kind of have a problem. So you just saw the first problem. And that was that one of these balls actually escaped. And right now you can kind of see that most of them go down the center, which is good. But if I start spamming the button, you'll notice again that we have some runaway balls to the left and right of the screen, which in the actual Plinko game does not happen. And there are some, you know, initial thoughts you might have as to how they control that. Maybe their physics are so good that it just never happens. And that could be the case. I have no idea because I have no access to that code base. Now, what I considered as a way to resolve this is to actually create an invisible collider, basically called a segment in PyMonk, that goes up diagonally, basically from this point here to this point here, right? And then do another one from this point here to the bottom right. And I did do that, and then I also had a different problem, is that I basically need a segment that goes from the leftmost obstacle on the top row straight upward, right? Because other times I'd like bounce over and I wouldn't actually be stopped by the segment that's going from the bottom left to the top left. So we're going to create an invisible segment that will keep the balls in bounds, basically, and will prevent that, as you can see, that one on the right, and inevitably we will see one on the left as well. But other than that, the game looks great.